Now I'm going to have a look at similarity. Similar figures. All corresponding angles have to be the same and all sides in the same ratio. There's basically two methods you can use. The first one is find the scale factor. And to find the scale factor, it's the new side over the old side. The other method is to cross multiply, or you put corresponding sides over each other. So new side 1 over old side 1 equals new side 2 over old side 2, and you cross multiply. Number 1. Prove two squares with sides 4 and 5.6 are similar. Now the conditions for similar shapes are all angles, corresponding angles must be the same. Now obviously all angles in a square are 90 degrees. So that angle is 90, so that one's 90. That's 90, so is this one. And these two match, and these two match. But you'd have to state that so the examiner knows you know that condition. So all corresponding angles are equal. Now you want to check the ratio for each side. So if you take each side in turn, you can see, if I take the top, the scale factor is 5.6 over 4. 5.6 divided by 4 is 1.4. If I take these two sides, 5.6 divided by 4 is also 1.4. So you can just simply state all corresponding sides are in the same ratio or have the same scale factor, both means the same. Number 2, I'm going to show you it through both methods. You've got similar shapes here. First method, method 1, is to find the scale factor. So the scale factor, to do that you put corresponding sides over each other, 3.5 over 2.8. which is 1.25. And then to work out x, you take the old side and times it by 1.25, which gives me 13 centimetres. And to work out y, you're going backwards. So you take your side and you divide it by your scale factor. So 1.375 divided by 1.25 gives me 1.1 centimetres. Method 2 is to put corresponding sides over each other. So you would start off 2.8 over 3.5. And to get the x, because I started with this shape, I must start with this side here over x. Then you cross multiply. 2.8x equals 3.5 times 10.4. To work out the x, bring that over and divide. So it's 3.5 times 10.4 divided by 2.8. So 3.5 times 10.4 divided by 2.8 gives me an answer of x equals 13 centimetres. To get y, I have to go through the process again. So you must, for this to work, you must pick two sides that you know. So put them over each other equals y over 1.375. I don't need to cross multiply here. I can just bring this across and multiply. So 2.8 times 1.375 over 3.5. So 2.8 times 1.375 divided by 3.5 gives me an answer of 1.1 centimetres. Now similar triangles. Easier if you draw out both triangles separately and rotate them so the angles match. If we look in these few examples, you'll see what I mean. Prove angle COD. So I want to draw out COD and FOE are similar. Now these are parallel lines. So the angle at C matches the angle at F. So I want that F up here. Opposites are equal. So I want my O here. And then my E will be down here. Now I need to prove that I'm drawn in the right direction. So this angle and this angle are equal. So angle DCO equals angle, sorry, it should be that one there, F. So equals angle EFO. And the proper name for that is Z angles, but you need to give it as alternate angles equal. Z goes the other direction as well, so you've got your D and your E equal. So that angle equals this angle. So that angle, to give it properly, is CDO. CDO equals FEO. Equals angle FEO. And again, state why. Alternate angles equal. And these angles in here at O are also equal because they're vertically opposite. So we need to state that. So angle COD equals angle FOE. And the reason, vertically opposite angles equal. Number 2, prove triangles ABC and BDC are similar. So I'm going to draw them out separately. So A, B, C, and that's 17, and that's 8. By Pythagoras I can work out that side there. So 8 squared add AB squared equals 17 squared. Bring that over. AB squared is 17 squared minus 8 squared to give me 225. So AB is the square root of that, which is 15. I'm going to draw out this next triangle, the same shape. So BCD, 31.875, the angle 17. I can work out this side by Pythagoras theorem as well. So 31.875 squared add 7 squared equals CD squared. So 31.875 squared add 17 squared. And then to work out CD, you'll square root your answer to give me a side in there of 36.125. Now, you want to prove all sides are in the same ratio. So I'll take each side and put it over the corresponding side to find the scale factor. So 31.875 over 15. So 31.875 divided by 15 gives me 2.125. Check it for the other two sides. So scale factor is 36.125 over 17 divided by 17 gives me 2.125. And then check it for the last side. 17 over 8. 17 divided by 8 is 2.125. So you need to state all sides in same ratio. Got to check all your angles are the same. Angle A and B are the same. So you need to find another angle. Doesn't matter which one you work with. We'll work with this angle C. So hypotenuse, opposite, adjacent. Because I know all sides, it doesn't matter which ones I circle, so I'll just go for opposite and hypotenuse, which is sine. So sine the angle at C is opposite over hypotenuse. So C is inverse sine 15 divided by 17. So that angle in there is 61.9. So that there is 61.9. And to work out this one, that's 90. Add 90. Take it away from 180. So that angle in there is 28.1 degrees. Over here, we've got to prove the same thing. So we'll find angle C, hypotenuse, opposite, adjacent. I'll just work with the opposite and hypotenuse again. So sine C is opposite over hypotenuse. You'll bring your sine over and do inverse. So inverse sine 31.875 divided by 36.125 gives me an angle of 61.9, which is what we had for the other triangle. To work out that last angle, add that to 90. and take away from 180 to give you 28.1. So you must state all corresponding angles are equal. So all corresponding angles are equal. Therefore, 3 dots means therefore the triangles are similar.